Hello, I'm Daniel Scully. I'm a particle physicist here at the University of Warwick. I'm here to talk to you about the Higgs boson, what might be the biggest discovery in physics in my lifetime. Particle physics has a problem. It can't explain why things have mass. If you pick anything up or try and move it, you can feel it has mass. You know it has mass. So this is a problem we need to solve. Over 40 years ago, Peter Higgs and several of his colleagues suggested that a new force, the Higgs force, might be responsible for it. The Higgs force is kind of like a cosmic treacle. Imagine trying to walk or wade through treacle. It would pull you back, slow you down, make you feel really heavy. And this is how the Higgs force works for particles. But does it really exist? How would we know? For every force in particle physics, there's a particle to go with it. So if the Higgs force really exists, we should be able to find the Higgs particle, also known as the Higgs boson. So how are we going to find the Higgs boson? Well, if it does exist, it'll be very heavy. It'll need a lot of energy to make it. That's how we make things in particle physics. You collide particles together at incredibly high energies, and all that energy goes into making new particles. So that's why we built the Large Hadron Collider at CERN in Switzerland. It's the largest, most powerful machine that human beings have ever built. It fires beams of protons around a 17-mile track, and then fires others in the opposite direction. They go to higher and higher speeds until you collide them together at incredibly high energies. Most of the time, all that energy will go into making particles we've seen before, but every so often they might go into making something new. If the Higgs boson does exist, every so often they'll make one. So what was all the fuss about in the news recently? Well, the scientists at CERN say they've discovered a new particle, one we've never seen before. But is it the Higgs boson? Well, it's where you'd expect a Higgs to be, and it behaves very much like a Higgs. This was the champagne moment, the discovery of a new particle in a region of physics we've never had access to before. The Large Hadron Collider was an incredibly expensive device to build. How can we justify funding such an expensive project without any immediate practical gains? To be honest, the Higgs boson will probably never make a difference directly to your life. After all, you'd have to have a Large Hadron Collider in your living room in order to even make one. But when we designed the world's largest, most powerful machine, we weren't actually capable of building it. In order to do so, we had to improve electronics, computing, engineering. All these industries have been driven forwards by the need to get to the highest energies ever achieved. But who knows what advances will bring? Over 100 years ago, X-rays were fundamental physics with no clear practical application. But today, you'll find one in every hospital, saving lives all the time. So who knows what developments we get from the Higgs boson today will bring tomorrow.